Problem. Imagine you found an abandoned well. So you stand at the edge of the deep well and you don't know how deep it is. How to find out? You drop a rock and then you count how many seconds until you hear the sound back. This is the problem that we will solve. So the total time that you counted is 4 seconds. Question in our problem is to find the depth of the well. So let's choose the x-axis direction up. Actually y-axis direction up. Then our acceleration due to gravity will be negative. Since we just drop the rock, initial velocity is 0, and what happens here when our rock drops and hits the ground at the bottom of the well, this sound will come up and we'll hear the sound. So the actual movement will be from us down to the bottom and from the bottom up to us. And from the bottom up to us it will be speed of sound 330 meters per second. So the total time is the sum of 2 times. First time, time of the rock falling down, and second time, time of the sound coming to us, coming up. Let's consider standard equations for acceleration due to gravity. So this depth of the well will be our delta s, the distance of rock falling down. And since initial velocity is 0, and well, let's say, which in this case we'll just calculate the actual distance. So we'll take absolute value of acceleration due to gravity, and we'll take our delta t1 time. Delta t1 is time of rock falling down. The same distance, the sound will go to us up. So, but it will be a constant speed of sound, and it will be delta t2. So it will be that delta t2 sound, time of sound coming up, and so the both distances are equal. So let's create an equation here. So we have this left side, this right side, they're equal. Instead of delta t2 we put delta t total that we know minus delta t1. Let's simplify and we'll get a standard quadratic equation. Solve quadratic equation and we'll get delta t1 equals 3.78 seconds. Therefore delta t2 is 0.22 seconds, together 4 seconds. Since this speed of sound is pretty high, we see that the time of sound coming up is time is pretty low. Now then we can place our found time into either of these equations, and we'll find either way. We'll find the depth of the well. Now let's consider how it looks on graphs. Graph of coordinate as function of time, and graph of velocity as function of time. So we have two movements here. First falling down with acceleration, and second straight line sound coming up. For velocity it will be a linear function for falling down, and will be constant because velocity of sound is constant. It will be constant coming up. So for the first movement, standard equation, t0 equals 0 here. So delta t becomes just t. Y0 equals 72 because we choose the point 0 at the bottom of the well. So that we start from this y1. This is our equation. This is our graph. This is number 1. This is rock falling down. Number 2. So this is acceleration with constant velocity, velocity of sound. In this case, very important. We see that t0 in this case is not 0 because we start here. It's exactly delta t1, which is 3.78 seconds. T0 equals 3.78. Y0 here equals 0. When we place number into this into this equation, we'll get simplify and we'll get our linear function. And very important again, t0 is not 0 here. For velocities, when we move with acceleration, this is the standard equation. Simplify, we get v equals negative 10t, linear function. And for speed of sound, it's a constant speed, so we'll just have constant function, this graph number 4.